Hello, welcome back. We're trying to find the limits at infinity for a given function. And we have a very special function to work with. It's the difference of two terms. One is 4x and the other one is the radical 16x squared minus x. So really, you can just pass the limit and see what kind of behavior you observe. Well, as you see, 4 times x is going to approach infinity because of x approaching infinity, right? So this is going to be infinity. And as well, so you have the highest degree term here to be x squared out of this expression in the radical. So inside the radical, the function approaches infinity. So the radical of infinity is still infinity. Radical of a large number is still a large number. So you have essentially infinity and infinity minus infinity. What does that mean? Well, you have a large number and you're subtracting another large number from that, because these numbers are not essentially the same. These are just limits, right? So all I know about these infinities is that, these guys grow without a bound, but I don't know how fast they're growing or how big they are. They're going to get bigger for sure, but we don't know how big they are. So we can't really conclude here that infinity minus infinity is 0. So this is another kind of like behavior that you have to have a deeper analysis to see exactly where this function approaches as x approaches infinity. So we're given a hint in the statement of the question. The hint is treat the expression as a fraction whose denominator is 1 and rationalize the numerator. Well, this kind of trick is generally used in algebra. So essentially what I'm going to do is I'm going to divide this by 1 and try to multiply this by another rational function so that I can do some simplification. So the question is like, what am I going to multiply this by? Algebra, this is called multiplying an expression by its conjugate. What that means is you have the difference of two terms here. One is 4x and the other one is the radical term. We are going to multiply this by its conjugate, meaning that we're going to get the plus version of that quantity. We're going to look at the sum of these two quantities and multiply and divide. So what is the benefit of doing that? Well, as you see that the top and the bottom would sort of like cancel out some of its terms after we expand it out. Let me just write it down clearly. All right, here we go. This is the full expansion of the top. We just multiplied everything term by term, like 4x times 4x, 4x times this radical times 4x, and this radical times this radical. Okay? As you see that the middle terms are negatives of each other, so when you add them up, they're going to cancel out each other. And here we go. We have 16x squared coming from here. And then if you take the square of the radical term, you have 16x squared minus x. Here we go. And then we have the minus sign here, so we just kept it forward. All right, so 16x squared cancels this 16x squared. And then at the top, I have only x left. Let me just clean this and see what's going on. All right, after the cancellation, we have x at the top. We have 4x plus 16x squared minus x at the bottom. Well, x approaches infinity, so the top is going to approach infinity. That's fine. And in the bottom, we have x term, and we have a radical term. So this approaches infinity. Well, the leading term here, or the highest degree term here, is 16x squared. So this is acting like infinity squared, but under the radical sign. So that's going to be almost like infinity plus infinity. So this is almost like infinity over infinity. This is another indeterminate form. Like in the beginning, we started with infinity minus infinity. We were able to convert this into infinity over infinity. This limit is going to be the ratio of the leading terms of the highest degree term at the top and the bottom. Okay, well, I know the highest order term here, that's x. The coefficient of that is 1. And here I have another x here, 4, but this is also mixed up with this radical term. So why don't we first apply some algebra or simplify this a little bit so that we can pass the limit rather than using the fact in a very raw way, okay? So let me do this. So x approaches infinity. I have x at the top. And let's say I have x factored out here. so that I have 4. And then I have like radical 16x squared minus x. So to handle that term, what I'm going to do here is that I'm going to factor x squared out inside the square root. So I'm going to left with 16 minus 1 over x. Okay? So I have x squared out, but since I factored x out, I should divide this whole radical expression by x. So x, another x, 4 plus, well, this is radical x squared times 16 minus 1 over x. I'm going to write it as the product of two radical terms. One is radical x squared. The other one is radical 16 minus 1 over x. Well, radical x squared is just x, okay? And in fact, there's another x here that cancels this radical x squared. So in the bottom, we're left with x times 4 plus this radical expression here. Let me just rewrite this. All right, this is what we have after all cancellations. And then now we can let x go to infinity. Here we go. 1 over infinity is approaching 0. So we have 1 over 4 plus square root of 16. But square root of 16 is 4. So this is going to be 1 over 8. Okay? So this limit, at first, it was looking like infinity minus infinity. And then we converted that into infinity over infinity, and we found out that this limit approaches 1 over 8. What that means is that this function here, 4x minus radical 16x squared minus x, has a horizontal asymptote, okay, y equals 1 over 8. All right, here's the graphical outlook of 4x minus radical 16x squared minus x. As x values approach infinity, the corresponding on the blue curve are going to approach the limit value, which was found to be 1 over 8. So this red dashed line is the horizontal asymptote, y equals 1 over 8. All right, this is the end of the video. Thanks for watching. I'll see you in another video. Bye.